Hello, students. Okay, so before I go and talk about the questions on the My AP review, I would like to discuss three theorems that we learned this year that will most likely show up on the AP test. The first one is the extreme value theorem. Now, our book, the Larson book or the Stewart book, doesn't talk about it too much, but it's starting to show up a lot on the AP tests. So it's important that we understand this. The extreme value theorem says if a function is continuous on the closed interval a to b, then f has a global, and that's the same as absolute minimum, and a global maximum on that interval. In finding the optimal value of some function, we look for a global minimum or maximum depending on the problem. So the first two lines is the extreme value theorem, basically saying that as long as our function is continuous, there's got to be the absolute highest value, y value, and there has to be an absolute lowest y value on that function. Even if it is a horizontal line, if you think about a horizontal line, there is one max value and there is one minimum value, and they happen to be the same thing. Okay, so it has to do with the y value being less than or equal to everything else. All right, for the IVT, intermediate value theorem, your function has to be continuous, just like in EVT. But what you do is you look at the endpoints, the y values of the endpoints, and you're in search of an x coordinate in between a and b within the closed interval, such that the f of c is equal to the y value that you're looking for. Okay, so in order for this to happen, the function has to be continuous. It doesn't necessarily have to be differentiable, but it does need to be continuous. And the endpoints, your y values at the endpoints must not be equal to each other. And the k must be in between those two y values. And the last one is MVT, mean value theorem. And this one is the function must be continuous and differentiable on the interval. And this one, the slope of the tangent is equal to the slope of the secant. So you can see how I color coordinated each of those expressions so you can see how they're related to each other, okay? And they can use various terms to basically mean the same thing. So it's important to keep each of these theorems in mind, and if you have your cheat sheet, it's a good idea to probably have each one of these. Just make sure that you understand them before you're actually taking the test. Okay, so here is the handout that we're working on. Okay, so number one, it says that you have a table of a function g. So, okay, let me look at this table. I can see that I have various values. They're not going up in the same, the delta x is not the same. And I can see that these values look like they're increasing. They look like it. There are various values of function g at selected values of x. Which of the following statements, if true, would be sufficient to conclude that there exists a number c in the interval 0, 7 such that this, okay, if true, and it has to be sufficient such that c in the interval of this, so this is acting like my a to b, such that when I put my c in, I'm going to get 50. Okay, so if I think back at my theorems really quickly, I know it's not going to be mean value theorem because they're not talking about anything about being differentiable or slopes. So I know it's not going to be mean value theorem. It could be extreme value theorem or IVT. But now extreme value theorem talks about having an absolute minimum or maximum. So it's most likely not EVT. So let's look at IVT. This is talking about that we're searching for a c inside an interval where that f of c is equal to a specific y value, which is what we've got over here. Okay, so we would be using intermediate value theorem for this problem. So now, when we think about intermediate value theorem, what do we need in order for intermediate value theorem to work? We need it to be continuous. That's the only thing that we need. And then we just need to make sure that our endpoints are not equal to each other. So first off, let's see. Are the endpoints equal to each other? No. So f of 0 is not equal to f of 7. Okay? Just to go back, f of a is not equal to f of b. Okay? So now I've got that. Now I need to make sure that this is continuous. I can see number 3, it says that this is continuous. Okay, now let's look about each one of these. Let's see, g is defined for all x in the interval 0 to 7. Okay, so when they say g is defined for all x, that means that for every single x on the interval 0 to 7, g has a y value for it. Okay, now it might sound like that means it's the same as continuous, but it's not. For instance, I could have a function g starts off at 0 and 24. And I'll say that here's 3, and I'm going to say that this is 42. And 1 is going to be 35. 1. Okay, so I don't know. And then I've got 7, and that is going to be 68. I'll say it's got something like that. Now, I could have other values in between. Let's say I got all the way up to 6. And let's say call 6 49. Oh, yeah. I'm going to say that that's closed. And then this one right here is open. For the same x value. Now, if you look at this, all of my x's have a y value. There is a jump discontinuity at 6. So, for this function, g is defined for all x on the interval. Yeah, because on the interval from 0 to 7, all my x's have a y value, including 6, even though that there is a jump discontinuity. But did I skip 50? Yes, I skipped 50. So that means that this cannot be one of them. Okay? G is increasing for all x on the interval. Well, if I look at this, this is increasing and this is increasing here. But again, there's a jump discontinuity. So I could have skipped 50. Okay? So the only thing that will make sure that we have an x value where the y value is going to be 50 is if the function is continuous. So that would be B. Okay? All right. The second one says let g be the function given by this expression. Which of the following statements could be false on the interval of this? Okay, so I've got an interval. All right, so this is like my A and B. Okay, and it's equal to, so that's closed. Okay, and here's my function. So now it says which be false. So I need to remember false. Okay, so let's go through each one of these. By the extreme value theorem, there is a value c such that when you put c into your function, its y value is less than or equal to all the other y values on this interval. So basically what this is saying, such that there is an absolute minimum. An absolute minimum is a y value that is less than all the other y values, or equal to if it was a horizontal line. By the extreme value theorem, there is a value c such that this. Okay, that means there's an absolute maximum on this. Okay? By the intermediate value theorem, there is a value c such that, okay, this makes no sense to me because when we talk about intermediate value theorem, we're talking about g of c equaling some y value. And by the mean value theorem, there's a value c such that the derivative is equal to the slope of the tangent. And we know that that would be. So which could be false? That would be this one right here. Okay, and then the last one. It says a particle moves on the hyperbola x, y equal to 15 for time t seconds. At a certain instant, x equal to 3, and that says dx dt. I know it's hard to see. I'll write it down. Is equal to 6. Which of the following is true about y at this instant? Okay, let's see. So I have x times y is equal to 15, and we're talking about t seconds, so that means that we're going to do everything with respect to t. So first, let me write it like this, because I think it'll be easier to take the derivative instead of doing the product rule. Okay, so now I'm going to take the derivative. So dy dt is equal to, when you take the derivative of this, remember, this is the same thing as 15x to the negative 1. So when you take the derivative, it's going to be negative 15 all over x squared dx dt, because you're taking the derivative of each variable with respect to time. All right, so now I'm going to substitute my values in. So I'm going to say dy dt is equal to negative 15, 3 squared times 6. So that means dy dt is equal to, that's going to be negative 90 all over 9. So that means dy dt is equal to negative 10. All right, now let's go look at my choices. What are my choices? Okay, it says y is decreasing by 10 units per second. Decreasing because it's negative. Y is increasing? No, because it's negative. If it was increasing, it would be positive. Y is decreasing by 5. Well, we got a 10, so goodbye. And it has to be positive. So that leaves us with A, which matches up exactly with our answer. Okay. All right, well, thank you very much.